Hello again, and as requested, we have question 23 from the IGCSE Maths Extended 2017 October-November paper 2. Okay, so we have a sector of a circle here, and if I'm reading correctly, the diagram shows a sector of a circle with centre O here, or the origin, with a radius of 6 centimetres. The sector angle is 30 degrees. The area of the shaded region, so this area here, is k times pi minus c centimetres squared, where k and c are integers, aka whole numbers. Okay? Find the value of k and the value of c. Now, the first thing I think when I see a problem like this is what do I know about sectors and what do I know about areas? Okay, so we have a sector of a circle. Now, I know that the area of a circle, and let's go for green today, green flavour. I know that the area of a circle is equal to pi r squared. I know that. But I don't have a whole circle here. I've only got a sector. I've only got a part of the circle. In fact, it tells me that I've got 30 degrees, and I know that a whole circle is 360 degrees. So I've got 30 over 360 degrees of a circle. So the area of my sector, and let me go here, yep, the area of my sector is going to be equal to 30 degrees of 360 degrees multiplied by pi multiplied by the radius. In this case, we're being given 6 centimetres, 6 centimetres squared. Okay? All right. So, the area of my sector. Now, if I simplify this fraction here, 30 over 360, we're going to get 1 over 12. And remember, you can use a calculator for this paper, so don't be scared to use your calculator if you need to use it. So 1 over 12 times pi times 6 squared, which is 36 centimetres squared. And then if we multiply 1 over 12 by 36, 36 divided by 12, we'll end up with 3 pi. Okay, so I know, and now I've solved for the area of all of the sector. Okay, and now I'm thinking else, what other information do I know? Well, what I can actually do is I can figure out the area of this area of this shaded region here by taking away the area of this triangle. And I remember another formula that we're given to find the area of a triangle where we don't have the perpendicular height. What we do need is we need to have 2 of the sides and the centre angle there. And that's the sine rule that we use for the triangle. So because this is a radius here, I know that this is also 6 centimetres. Okay, so my area of a triangle is going to be, so the area of a triangle using the sine rule is going to be half multiplied by A multiplied by B multiplied by the sine of C. And if I remember how to label my triangle, I can call this lowercase a, I can call this lowercase b. That means that this is lowercase c, so my angle is c up here. So I can substitute these values into here. So my area of my triangle will be half multiplied by b multiplied by sine. Now, again, you guys have a calculator, so you can figure that out, that's going to be half of 6 is 3, 3 is 18, and the sine of 30 is actually a half. So this is equal to 9. So my area of the shaded segment, and let's use a different colour here, the area of shaded will be equal to the area of the sector, so the area of the sector, okay, minus the area of the triangle. So that's going to be equal to the area of the whole sector is 3 pi minus the area of the triangle here, which is 9, and that's all centimetres cubed. And if we have a look at that, we can see that that's actually in the form of what we've been asked here. And I can see I've got my 2 integers. I've got my 3 and I've got my 9. So the solution to this problem is going to be k is equal to the coefficient of pi, which is 3, and c is equal to 9. And that is our solution right here. Okay. Please don't forget to comment on this if you have any further questions. And if you do want any other questions to be solved for you, just comment and ask, and I'll do my best to do them for you. All right? Cheers. Cheers.